So this section on Delta Math is about procedures, which is just another name for functions. This is written in a type of pseudocode. So kind of different things here that would work the same. These arrows mean equal to signs. They kind of like a function, have brackets around what goes in this procedure. So it kind of looks enough like JavaScript that you can figure out what's going on. So we have a function or procedure called mystery that takes 3 parameters and returns this expression from those parameters. So the first thing that's happening is we're running mystery for the numbers 7, -1, and 2, and we're storing it in answer, and then displaying answer, which is another word for print or console log, depending on what language you were looking at. So I'm going to write mystery 7, -1, 2. So this is A, B, and C. So we're going to plug them into this expression. So that's going to be 2 minus 7 times, they have kind of like a weird symbol for it, the star, -1. So just like anything, we follow PEMDAS, computers follow PEMDAS as well. So we're going to multiply these two together. So I get 2 minus -7. So the answer to this one, when I simplify that, is going to be 9. So basically, this is equal to 9. It gets stored in answer. Like this is an equal sign. Answer is equal to that. So your answer that you would write on Delta Math, we're just displaying that 9. So that goes along with the first level. The second level I'm going to put in the same video. These are just with 2 functions, and then you have to do something with them. Maybe one first and the other. Maybe subtract them or someone. So we have 2 procedures, one F and one G, just named by a letter. And this is what we want to find. So just like anything in math, computer science, we're going to follow the order of operations, and we're going to start from this inner one. So we're going to find the G with parameters 1 and -5. And actually, to correct my speaking, C and D are the parameters. When we plug numbers in, these are called arguments. Okay, things that we plug in for parameters, actual values, are called arguments. So now we're going to do C minus 3D. So C is -5. Nope. C is, and that's why it's always good to label these, even though they are in alphabetical order. C is 1, right? And then D is -5. So this is 1 plus 15 is 16. So that means because we're returning this value, the value of G with parameters 1 and -5 is 16. So now we're finding F of 16, 5. So I'm going to use a different color and kind of go up here and write this next to the F function. So 16 and 5 are my arguments. So I have -2 times 5 minus 3 times 16, just plugging them into this expression. So this is -10 minus 48, which is -58. So now that we found F of 16 and 5, that's our last thing. This evaluates to -58, which gets stored in the answer and then displayed. So your answer would be -58. The next one I'm going to do a little faster. I just wanted to show that you could also subtract 2 functions. If you feel okay at this point, you may not need to watch this part of the video, but if you want to, you definitely can. So this is also a level 2. Now we have 2 functions, F and G. And looking down here, we have the F function minus the G function. So they're kind of separate now. We're going to find each one and then subtract them. So I'll do F of -3, -2. This is my Y and Z values. So this is -2 times -2 plus 2 times -3. So for this one, we have 4 plus -6. And I plugged them in wrong. And I don't feel like making over the video totally or editing it, so I'm just going to erase this. Okay, so we're doing -2 times Y, which is -3. Z is -2, so I just have to make sure I plug them in the correct spots. So this is -6 positive 6 minus 4 equals 2. So this part evaluates to 2. Now we'll do the g function. So g of 4 and negative 4, this is my y and my z. So this is negative 4 minus 3 times 4. So here we have positive 4 minus 12 is negative 8. So now we have 2 minus negative 8. So this is 2 plus 8, which is 10. So that is our answer.